Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals, and here we'll make use of some properties of definite integrals to evaluate this integral, right? And moreover we'll make use of some important identities from trigonometry to simplify this function, that is 2 minus cosine of 2x, right? So let us start, and let us first take this integral as I, right? So now if we look at this integral, we see that here the integral is minus pi by 4 to pi by 4, and we have dx over 2 minus cosine of 2x, right? So what we will do here, first of all we'll make use of an important property from definite integrals, which is minus a to a f of x dx is equal to 2 times of 0 to a f of x dx, right? So whenever we have an integral of this type, that is minus a to a f of x dx, this integral is equal to twice of the integral 0 to a f of x dx, provided that this function f of x is an even function, right? So by even function we mean that if we replace x by minus x, then again we get the same function, right? See, for example, if we have cos x, then if we replace x by minus x, see, again we get cos x, right? So cos x is an even function, right? So here see, in the integrand we have 1 over 2 minus cos of 2x, right? So we have this function as the integrand. Now if we replace x by minus x in this expression, then what we will get, f of minus x is equal to 1 over 2 minus cos of 2 times minus x. Here we'll replace x by minus x, so we have 1 over 2 minus cos of minus 2x, and from trigonometry we know that cosine of minus theta is equal to cos theta, right? So cos of minus 2x is equal to cos of 2x, right? So we have 1 over 2 minus cos of 2x. So we have again got the same function, that is f of x, right? So when f of minus x is equal to f of x, this implies that f of x is an even function, right? And when f of minus x is equal to negative of f of x, we say that f of x is an odd function, right? For example, sine function is an odd function because sine of minus x is equal to minus of sine x. Similarly, x cube is also an odd function because minus of x cube is equal to minus of x cube, right? So once we have established that this function, that is 1 over 2 minus cosine of 2x, is an even function, we can now write this integral by making use of this property, right? So now we can write this integral I as 2 times 0 to a, right? And for a we have pi by 4, so we have pi over 4 and dx over 2 minus cos of 2x, right? Okay, so now here we'll make use of another important identity from trigonometry, that is see, here we have cos of 2x, right? And cos 2x is related to tangent of x as 1 minus tan square x over 1 plus tan square x, right? So this is an important identity in trigonometry. So cosine of 2x is equal to 1 minus tan square x over 1 plus tan square x. So now if we take this function as 1 over 2 minus cos of 2x is equal to 1 over 2 minus for cosine of 2x, we can write 1 minus tan square x, and here we have 1 plus tan square x. And now if we simplify it, we'll get 1 over 2 times 1 plus tan square x minus 1 minus tan square x and divided by 1 plus tan square x, right? Now if we take this term to the numerator here, we get 1 plus tan square x divided by 2 plus 2 tan square x minus 1, and then we have plus tan square x. So we have 1 plus tan square x divided by 2 minus 1 is 1, and 2 tan square x plus tan square x is 3 tan square x, right? So now this integral I can be written as 2 times 0 to pi by 4, and we have dx here, and we can write here 1 over 2 minus cosine of 2x can be written as 1 plus tan square x divided by 1 plus 3 times tan square x and dx, right? So now we can again use one important identity from trigonometry, that is 1 plus tan square theta is equal to secant square theta. So this integral can be rewritten as 1 plus tan square x is secant square x, and we have dx divided by 1 plus 3 tan square x, right? Okay, now we have obtained this integral, and in order to solve this integral we'll make use of the method of substitution. So what we will get, we'll take t is equal to 10x, right? Because when we differentiate 10x, we'll get secant square x. So dt over dx is equal to secant square x. So dt is equal to sec square x dx, right? So the derivative of 10x is secant square x. And now here x varies from 0 to pi by 4. So when x is equal to 0, then t is equal to tan of 0, that is 0, right? So tan of 0 is 0. When x is pi by 4, then t is equal to tan of pi by 4, and tan pi by 4, that is tan of 45 degrees, is equal to 1, right? So now this integral I takes the form 2 times 0 to 1 secant square x dx is dt, and here we have 1 plus 3 t square, right? Because tan square x is equal to t square, right? So now let us solve this integral. So what we will do here, we'll take 3 common from 1 plus 3t square. So I can be written as 2. Here we have 0 to 1, then we have dt, and if we take 3 common, we'll get 1 over 3 plus t square, right? Now we can write this integral as 0 to 1 dt, and here we can write 1 over square root of 3 square plus t square, right? So 3 can be written as square of square root of 3, right? So here now this integral takes the form dx over a square plus x square, right? And this type of integral is equal to 1 over a tan inverse x over a, right? So this is a standard result in indefinite integrals. So this integral is similar to this one. For a, we have 1 over square root of 3, right? So now we have 2 over 3, and this integral can be written as 1 over a a is 1 over root 3, then we have tan inverse t over 1 over root 3, right? And the limits of integration are from 0 to 1. So now we can simplify this expression by substituting the limits and taking the difference. So we have 2 times root 3 over 3, and here we have tan inverse t times root 3, right? And the limits are from 0 to 1. So we'll take root 3 to the numerator. So we have t times square root of 3, and here root 3 is taken to the numerator. So we have 2 times root 3 over 3, right? So we have 2 root 3 over 3, and when we take t is equal to 1, so here we have square root of 3, because 1 times root 3 is root 3, and when we take t is equal to 0, so 0 times root 3 is 0, so we have here tan inverse of 0, right? So now we can write 2 root 3 over 3, and here we have tan inverse of root 3, which is equal to pi by 3, right? Because tan pi by 3, that is tan 60 degrees, is equal to root 3, and here we have tan inverse of 0 is equal to 0, right? So now we can further write this expression as 2 root 3 over 3 times pi by 3. So this is 2 pi root 3 over 9, right? So the value of this integral is equal to 2 pi root 3 over 9, which can also be written as 2 pi root 3 over 9. And if we take or we rationalize this expression with root 3, we have 2 pi times 3. Here we have 9 root 3. So this is 3 3s are 9. So we have 2 pi over 3 root 3, right? So this may also be taken as the answer for this integral, right?